So when we log into Max's MX Insight UI, the first thing you see will be the dashboard. This dashboard shows real-time cluster level statistics. Now, keep in mind, this UI and all the functionality that we'll walk through today is exactly the same whether you deploy Maxta in an OpenStack, KVM, or VMware environment. We'll come back to Max's advanced historical and real-time statistics later. But to get started, let's hop into a demo of what we spent most of our time talking about, the application optimizations that can be made through a few simple clicks of Max's VM creation wizard. One thing to keep in mind here is that you can create VMs either through Max's MX Insight UI or through the hypervisor's UI or APIs as you've been doing up until now. The only difference is that when you create a VM through Max's UI, you can set all of the policies on creation of the VM. Whereas if you create through the hypervisor directly, you would just need to modify those policies after creating the VM. To start with, you'll see a lot of the same fields that are filled in when you create a VM through the vSphere web client. So we'll provide a VM name, a guest OS type, some information on CPU and memory resources. Then we'll select a host on which the VM's compute resources will reside. You can also attach an ISO, so say if you want to install Windows 2008, you can go ahead and attach the Win2K8 ISO and have the VM power-ons directly into that installer. You can also specify any network connectivity. Now we get into some of the more interesting stuff that Max's storage platform is going to provide for you in order to have an optimal configuration for each VM and even vDisk within your environment. The first parameter that's available to you is number of replicas. By default, Maxta creates 2 copies of your data across the cluster. This allows you to survive any one disk or node failure with no downtime and no data loss. So now, let's say you have a VM that you want to have even higher availability or better fault tolerance for. You can go ahead, you can come in the UI, you can change the number of replicas to 3 or more, depending on the number of nodes in your cluster. Maxta will then go ahead and create more copies of your data, allowing you the ability to sustain more drive or node failures, again with no downtime and no data loss. Below replica copies, you'll see rebuild priority. When a disk in a Maxta cluster fails, we go ahead and randomly put all the VM and its associated data that was on that disk into a queue and automatically start to rebuild the data from that failed disk to other disks and nodes within your Maxta cluster to return you to a fully highly available state. But now, again, let's say you have a VM which you want to have higher availability or higher fault tolerance for. You can go ahead, you can set that VM's rebuild priority to 10, and we'll put that VM's data at the top of the queue to get rebuilt onto other disks in the cluster first. The next parameter you'll see is metro clustering, or what we also call rack awareness. What this means is, say you have 3 sites, or 3 racks within your lab in your data center. You can go ahead, you can set rack awareness through Max's installer and assign nodes to each of those 3 racks. So now, let's say you have a different power supply hooked up to each of those racks. With rack awareness or metro clustering enabled, Maxta will go ahead and place one full copy of a VM's data on site 1 and another full copy of that data on either site 2 or site 3. This way, if the power supply to site 1 fails, you'll have no downtime and no data loss because there would be a full copy of data available on the other racks in your data center. Maxta will simply redirect the I/O path to this healthy active copy of data. By default, Maxta stripes data across as many nodes and disks in your cluster as possible. This gives you the performance benefit of all the disks and all the nodes in your cluster, and also provides better data distribution as you scale your environment. However, we also recognize that there may be certain situations where you'd want to have a form of data locality. If you go ahead and you uncheck this box for striping, Maxta will use what we call vertical striping, meaning that instead of striping data across multiple nodes, we'll actually write one full copy of a VM's data to one node and stripe it across the disk within that node, and then of course we'll also write another copy of data to another node in the cluster for HA purposes. But now, when you're reading data from that VM, its storage and compute resources will reside on the same node, providing for better performance under certain workload characteristics. As you can see already, there's a lot of flexibility built into the Maxta storage platform when it comes to data layout within your cluster. One other feature we have for data layout is called node affinity. Node affinity allows you to select a group of nodes that you want to restrict a VM's data placement to. So let's say you have a 10-node cluster and 3 of those nodes are high-performing nodes with maybe NVMe SSDs and 15K RPM HDDs, while the rest are just standard nodes with SATA SSDs and 7.2K RPM HDDs. What you can do with node affinity is go ahead and select the high-performing nodes, say nodes 1, 5, and 8 in the node affinity group screen here, and Maxta will restrict the placement of that VM's data to the nodes you have selected, thereby giving you some level of performance isolation within your Maxta data store. On the next screen here, let's take a look at a few of the virtual disk level policies you can set when creating VMs on the Maxta data store. Now, what you'll see here is that you can add multiple vDisks to your VM and configure unique sets of policies for each of those disks. You can configure the size, so say 40 gigs for the boot disk. You can also go ahead and set parameters like page size, which is going to allow you to align your storage block size with the page size of the application. So, say you're deploying a VM from Microsoft Exchange, which typically runs at a 32K page size. You can go ahead and set the page size of that vDisk to be aligned with the application at a 32K block size. Similarly, if you're deploying another vDisk for a database, you can go ahead and set that to an 8K page size to align with the DB. You can also specify the SCSI controller type for your vDisk. Two other parameters you can configure are read cache and compression. So let's say you're using this vDisk to store media files or encrypted data, both of which really aren't going to be all that compressible. You can go ahead and you can disable compression for that particular vDisk, which would thereby free up CPU cycles for the rest of your cluster rather than being used to try to compress uncompressible data. Similarly for read cache, if you have a vDisk which has data that will be accessed frequently but doesn't require high performance, go ahead and uncheck the read cache box. This will free up space on the SSD's read cache for other VMs which require higher performance to consume that space on the SSD. And so now, after we've set all of our policies to create our VM's optimal configuration, we'll click Submit. We're redirected to the Manage VMs page and our VM is created in seconds. This view will show all VMs that reside on the Maxta data store, whether they were created through MX Insight, as we just did, or through the Hypervisor's UI. So, as I discussed earlier, if we had created a VM through the vSphere web client, we could still come into the Maxta UI after the fact and go ahead and modify all of those policies we just looked at, replica copy, striping, etc. I can also add a vDisk and configure all of those policies that were available when first creating the VM. Now that we've created a VM, let's go back to Maxta's dashboard view and take a look at what insights can be gained into our virtual environment. The dashboard has stats for capacity, latency, IOPS, and throughput aggregated for all nodes in the Maxta cluster. What you see here is real-time statistics, but Maxta also captures historical data for all of these stats, which can be seen by expanding the graph view. From this view, you can select to look at stats from a few hours or a few days back. Or if there was a failure over the weekend, you can even select a specific time period to look at. In addition to cluster-level statistics, we also break down the data on a per-node basis, giving you further granularity to better understand your environment. Node stats will show you the same data on capacity, latency, IOPS, and throughput, but now it's broken down on a per-node basis. Now, the one that I think is really cool is our VM-level statistics. On this page, you can see latency and cache hit or miss ratios broken down on a per VM or even per VMDK or virtual disk basis. We show you the Maxta intent log, or what we call our write cache on SSD, the SSD read cache, and the in-memory cache, in addition to any cache misses. This allows you as an admin to get a very good understanding of how each VM is performing and what resources they are consuming. And finally, as you can see at the top of the page here, we also have historical data available for the VM level and node level stats. And that's a quick run through of a few of the key features of the Maxta UI when it comes to advanced real-time and historical statistics reporting, along with the wide set of configurations that can be made on a VM or vDisk level to provide you with a truly application-optimized hyperconverged storage platform.